This is structural analysis and modeling portal section approximate methods of analysis of a 2D frame under gravity loads GSA tutorial part. For this tutorial, you should be able to learn how to build a simple frame model and define load cases for dead load and live load, as well as load combinations in GSA. So first of all, let's create a new file and populate the running info, which in our case is structure analysis and modeling model, and the subtitle can be the section's name. That will be approximate method of analysis of a 2D frame under gravity load. Structural type is space. The unit, you can choose kilonewton-meter, and beware of the unit here, the length small, because it's used to describe the cross-section size of the members. And the stress, if you find confused about this unit, which is Newton per square millimeter, you can just change it to megapascal and finish. Then we should go to check the material properties, because in our case we need to use a material called the concrete long-term. So let's go to the gateway menu, go to the properties, materials, standard. So we can see that the concrete long-term is one of the building materials in this program. But if you, when you do another structure model and you can't find the materials in the building part, you need to use the user define and use wizard to define a new material, populate the random info here. Okay, so the next is to define the cross-section properties. Just go to the gateway menu, properties, section properties, click on the first line, right click, choose wizard, or use the wizard tools from the top toolbar. Then we populate the name as column. Material is concrete long-term. Cross-section type is defined as rectangular. So the cross-section is 500 mm by 500 mm. So the unit of dimension now is 5 millimeters. So that will be 500 mm by 500 mm. Click on next and finish. Then we define a new one. Give a name as beam. Material is concrete long-term, rectangular. The same as 500 mm by 500 mm. Click on next and finish. After that, we need to define the nodal geometry. So go to the gateway menu, nodes, coordinates, and we should define the coordinates according to figure 5, which is at the bottom of this handout, like that. Okay. So according to that, we should import the first node will be 0, 0, 0. The second one will be 5, 0, 0. So the one is 10, 0, 0. The fourth one is 0, 0, 3. Fifth, 0, 5, 0, 3. The sixth is 10, 0, 3. The seventh is 0, 0, 6. And the eighth is 5, 0, 6. The ninth is 10, 0, 6. And then you can go to the graphic view. Open the label nodes dots and label nodes number, and right now it's a preview, so you can go to the click on the left hand toolbars Y elevation, so you can see the arrangement of the nodes should be the same as here in the handout. So then what we need to do is to define create the bin element. So first we click on the add element gap tool from the left hand toolbar. Then we open the data defaults from the top toolbars. Go to elements tab. So for the property 1, you can click on edit. So it's column. So we should first define a column, which is named for the nodes that's on the columns. Then we use property 2 and press edit. We can see that's bin. So we can link the bin here. After that, we can open the session display to see whether we define the session property right. So in this case, the dimension of the columns and the bins are same, but in the actual cases, the columns will be bigger than the bins. Yeah, so you can have a check whether you have built the property right. Okay, so we can close it. Then the next thing we should do is to generate the support. So there are two ways to do that. The first way is go to the gateway menu, and restraints, we restrain all the direction in not 1, not 2, and not 3. Okay, so we keep everything on yes. And that's one way to do that. And the other way is we can open the label string so we can see that we haven't defined it. Yep. You can see that not 1 is in cast, so it's fixed in all directions. So the other way to do that is go to the select nodes and select all the nodes at the bottom of the ground floor column. Right click, modify select nodes, and we just press in cast. So all the nodes is fixed in all directions. Then we need to define two load cases so that from the gateway menu, cases and tasks, lowercase specification. So we click on the first one, use result, and give your name as self weight analysis. The type is the dead load, and press OK. Then we click on the second one. We can right click on it, or we can double click and go to result. So give your name as, well, let's see, live load analysis. So the type is live load, and press OK. So then we have defined two load cases. Next, we should define the self-weight loading. So still go to the gateway menu, loadings, and gravity loadings, and click on the first line, use result. So give your name as self-weight loads, and element list is all. Then all the elements in this model will is included in these cases. So lowercase is lowercase 1 because it's self-weight part, and the gravity should input -1 in the z direction, as the note here says a normal vertical gravity load is z equal to -1, because in GSA the upward directions of the z-axis is the positive direction, so the gravity is going down, so the downward directions is the negative direction, so we need to input the minus before 1. Okay, then after that we can define the beam loading. So also there are two ways to do that. The first way is go to, if you know the numbers of the elements, which I click on the label elements number on the right hand toolbar. So we can go to gateway menu, loading, beam loads, and select the first one. Give your name as beam live loads. And beam list there will be 7, 8, 9, 10. And lowercase there will be lowercase 2, which is live load analysis, and direction is Z. Value that will be input as -10. That's okay. Then we can go to graphic view and click on the all load diagrams on the right hand toolbar. So first we can click on the select for animation on the left hand toolbar. So the first low case 1 we can see the self weight of the elements, and for low case 2 we can see the live load analysis, which is the live load applied on the beams. So the other way to do that is to go back, is to use select elements here, tools, and select the elements that we need to apply load. Then right click, create element loading, create a beam loading, give name as beam live loads. And beam list it has already generated, so we don't need to import by ourselves. And this is especially useful when you build a larger structure and you can't remember all the numbers of the elements. So low case is low case 2, direction is Z, type is uniform, axis is global, so value is -10. Understand? So then we can have a look again. Yeah, it's the same. Okay? So we can close this down. Then we need to define the load combination, so which is from the gateway menu, cases and tasks, combination cases. Click on first one, use wizard. So we can input the name as gravity loads, and description is A1 plus A2, which is the depth load plus live load. Here we input A1 and A2 instead of L1 and L2 because A1 and A2 here means analyze result for the low case 1 and analyze result for the low case 2. Post analysis it will be the static analysis, so you can see the description here. And then we can go to the graphic view, so you can see we have a case C1 gravity load. However, when you open the all load diagram now, you won't see anything. Okay, because you have to analyze the model first. So we click on the analyze all from the top toolbar to analyze the photo frame. Then we can go to graphic view. Notice the case is C1. We click on all load diagram and select coordination. So now we can see how the loads looks like. Okay, that's the combination of low case 1 and low case 2. Okay. Then we can view the deformed shape, which is click on the deformed image from the right hand toolbar. So we can see how the model is deformed. Okay, so right now it's only the gravity loads, which means it's only vertical. But if you add the point loads from the left or from the right, the deformed shape will become different. So we can see it in, for example, now we also input nodal loads, which is, the way of doing that is also either you remember the name of this load and input it in the gateway menu, nodal loading, nodal loads, which is, in our case, that will be load list 4 and 7. So you can even doing that, we also need to define the new load cases, which this part will be further introduced in another sections, but right now I can show you very quickly. So the type will be earthquake, and go to nodal loading. So 4 and 7, giving the direction of Z or X and value of 10. So let's have a look at graphic view. Oh, we need to change the low case to low case 3. And so right now we can view the load case 3 and open the all loads diagram, so we can see there are 2 loads applied on here. Using the set for nomination, you can see that. Or we can define the loads in a similar ways or implement it just before to define the beam loading. So now we can add a new combination cases, which is for the seismic loads. So that will be A1 plus A2 plus A3. So notice that here is just for illustration, so it's not any of the load combinations that is defined by the code. So you can see that now we have a second combination load case. We can analyze them. Then go to the graphic view. So see for the case 1, which is only the gravity loads, it looks like that. And for the second one, which also applied the horizontal load, the lateral loads, the building behave like that, the structure. Okay. So when you do the seismic design analyze, then you need to both apply loads in vertically and horizontally. Then we can check the shear diagram, which is on the right hand toolbars, FZ shear force diagram. So we can see the how the structure behave in different kind of load combination or different kind of load cases. You can also click on the select for animations on the left hand toolbars to see the actual value. And sometimes if you think the shape is too small, you can click on double size of diagram on the right hand toolbars, and you can make it smaller by click on the half size of diagram here, or you can click on the rescale data. Okay. Then the second thing is to check the axial load, which is here, Fx axial force diagram. So we also select them, so you can see the load value for different cases. Okay. Then we need to check the moment diagram, which is click on the MYY bending moment diagram. We can see the bending moment diagrams and its figures on the different load cases. Lastly, we need to obtain the support reaction, which is go to the control settings on the right hand toolbars and go to the model results, reactions, FZ, and here control based on actual value. So we can see that at here, according to the color, that will be around the value of 16.8. Here is 19.7. Here is 16.8, or maybe larger. So in this time, if you feel confused about the value like what I'm now, so you can select for animation and select these 3 values, so you can check them. Okay, so actually the value here is 16.3, not 16.8. Value here is 19.7. So then after you get this data, you can compare the results obtained from the GSA against those from the portal method, which you need to conduct by your hand calculations. Okay, so that will be all for the GSA tutorial part for the approximate methods of analysis of a 2D frame under gravity load section.